The topic of this video is building quadratic models from verbal descriptions, economic models. Let's look at a problem. The price P and the quantity X sold of a certain product obey the demand equation P equals negative 1/3 X plus 40, with 0 less than or equal to X less than or equal to 120. Part A, express the revenue R as a function of X. Part B, what is the implied domain of R? Part C, what is the revenue if 66 units are sold? There are other parts of this problem as well. We'll deal with them in a future video. Okay, so let's start with part A. Express the revenue R as a function of X. This is actually pretty easy to do. We have to remember the formula that R is equal to X times P. Revenue is equal to the quantity sold times the price. And in this problem, they give us what P is equal to. So we can replace that P with the negative 1/3 X plus 40. Whenever we replace something with something new in algebra, we have to check to see if parentheses are required. In this case, the P is a multiplying neighbor, so we do use parentheses. We'll use the distributive property here, and we'll write negative 1/3 X squared plus 40X. On the left, since it says to express the revenue as a function of X, we'll write it as R of X equals. This is our answer for part A. Part B, what is the implied domain of R? Well, domain is all of the possible input values for your function. This is our function. The input variable is X, so we're looking for all of the possible X values. Now, if you followed the 4 steps for finding the domain from an equation, you would conclude the domain is all real numbers, because for this particular equation, there are no even index radicals, there's no logarithms, and there's no denominators. Well, there's this 3, but there's no variable in it to make the denominator 0. But this question asks, what is the implied domain? This is a real-world problem. X represents a real-world quantity. In this case, it's the quantity sold of a particular product. The smallest number of something that you can sell would be 0 items of that particular product. And the problem specifically tells us that X needs to be between 0 and 120. So this is our domain. And we'll write it as the interval, bracket, 0, 120. This is the answer to part B. Part C, what is the revenue if 66 units are sold? Well, part of the benefits of creating an equation like we did in part A is it tells us the relationship between the variables, X, the quantity sold, and R, the revenue. If you know one, you can find the other. And that's exactly what we're doing here in part C. So we're going to use this equation. Everywhere we see X, we're going to put 66. So we get R of 66 is equal to negative 1/3 times 66 squared plus 40 times 66. Order of operations says that we have to do exponents first. So the first thing we're going to do is 66 squared. I'll use my calculator for that. 66 squared is 4,356. The rest I will leave unchanged. All right, we've done exponents, now we'll do multiplication. So this number needs to be multiplied by this fraction, and the 66 and the 40 also need to be multiplied. Let's deal with this first part first. A number in a denominator is actually dividing. So 4,356 divided by 3, then multiplied by 1, which doesn't change its value, then made negative, gives the result negative 1,452. 40 times 66, 40 times 60, this is me saying one thing and entering another. 40 times 66 is equal to 2,640. Now add the values together. Negative 1,452 plus 2,640 is 1,188. And since this is revenue, it's $1,188. So when 66 units are produced and sold, the revenue is $1,188. All right, we've now completed parts A, B, and C, and the other parts will be completed in the next video.